Thank you for joining us here in the International Space Station Flight Control Room. As we've mentioned several times, this week marked a big milestone for the onboard crew, specifically Scott Kelly and Mikhail Kornienko, who passed the midway point of their mission. Here to help talk about that is Associate Manager for the Human Research Program, Dr. John Charles. Thanks so much for joining us.
Delighted to be here. Thank you for the chance.
So let's set the stage again for why we even embarked on a one-year mission. What were the goals of having a couple of crew members stay up there for twice the duration of the normal crew?
There are several goals. One was to start getting into a Mars mindset. Mars missions will be probably 2.5 years long. We've got a lot of experience with 6-month missions on the International Space Station. Inevitably, there's going to be somebody that says, how about the gap between 6 months and 2.5 years? What are you doing about that? And so a Russian proposal was submitted, and it was accepted by the American side to do a one-year increment to start thinking about the aspects of a one-year mission or a Mars mission. But the part that interests the Human Research Program is really a chance to, like I say, see if we've done our homework correctly. We've got lots of experience with 6 months and other shorter missions. On the International Space Station, on the Russian space stations, a whole long line of them, on the American Skylab, 3-month missions, and lots of experience in spaceflight in general. We think we've learned how the human body responds to spaceflight. So here's a chance to test it and see whether we can predict changes that might occur in a one-year mission and how close our predictions are. Generally speaking, our predictions are there shouldn't be that big a difference. We think that the 6-month flights pretty much show us what's going to happen to the human body with a long space flight. Wouldn't it be nice to know if we're right before we start committing to longer flights? So there's a chance to acquire data on human adaptation to long-duration spaceflight, and also to verify our countermeasures, those things that we have, those techniques we've developed to allow us to give astronauts and cosmonauts confidence they can go forward with known medical changes in their bodies, and see whether they really do work on longer missions. So a good outcome for this mission will be no surprises.
So one of the major activities they've been doing this week is part of the fluids shift research. They're even working on that today. Can you tell us a little bit about that? I know part of that was to look at, obviously, the fluid shift changes and specifically changes to vision, which has been observed in some crew members.
Astronauts on previous space station missions, not that far back in the past, in the last 7 or 8 years, have reported decreased visual acuity with time in flight. We had always seen changes in visual acuity on shorter flights, even on shuttle flights, but it was always of a variable nature and never long-lasting enough to really concern the flight surgeons in a significant way. But about the middle of the last decade, or slightly thereafter, some astronauts were reporting that they were losing a lot of their near visual field and unable to do things like read a checklist, which is kind of a bummer when you're trying to fly a Soyuz back to a landing. So we became motivated to understand the problem. The problem seems to be related to an actual change in the shape of the eye, of the globe of the eye in spaceflight, a flattening of the globe, as if there is a force pushing against the back of the eye and making the eye's focal length shorter. What could be doing that? Well, and that's based on direct measurements with ultrasound and pre and post flight measurements with magnetic resonance imaging. So it's pretty real. It's not a hypothesis per se. One of the things that happens in the human body is the body's body fluids distribute equally up and down the entire body, which has the effect of being a net headward fluid shift, hence the name fluid shifts. If fluid shifts are implicated in the loss of visual acuity because of pressure pushing on the back of the eye, and presumably the fluids would sort of accumulate in the upper part of the body, fill up the spaces in the head, and then look for other places to go, like along the optic nerve tracts, wouldn't it be a good idea to see if we can reverse that with a device that uses lower body negative pressure? Well, it just so happens the Russians have one of those LBNP devices on the station. It's called CHIBIS. It's part of their usual end-of-mission countermeasure. So we have asked permission and actually have a joint study, a joint U.S.-Russian study, to do Chibis measurements on Kornienko and Kelly 3 times in flight. The first one was in June, the second one is this week, and then once more before landing, to see if we can document with a change in the fluid distribution, a change in the shape of the eye, and a change in other parameters that indicate the fluid shifting in space. So it's a very complex, highly integrated, probably the most complex biomedical investigation ever done on the station, and I like to think it's one of the most complex of any investigations done on the station. Highly integrated between the U.S. and Russian sides, and between the engineering and the scientific communities. So it's a real challenge, and our teams have been doing an excellent job on it so far.
In addition to the changes in the vision and the physiological effects on the eye, are there other physiological types of changes that you're looking for with the crew members?
Well, in fact, there are. I just heard a brief mention in your early report about Sprint. That's an exercise study to evaluate different ways, more efficient ways to do exercise on astronauts so they don't spend quite so many hours a day treadmilling or exercising. We have the usual set of measurements of the blood components, trying to track the changes that happen in the body's metabolic pathways in space. And it should be noted that the studies that we're doing on the 1-year mission are the same as we do on 6-month missions. They're not a separate set of investigations for 1 year, because we're looking for differences between 6 months and 1 year. And you want to do the same measurements and then see if the data are the same or different. But there are a whole set of physiological studies, psychological studies, and space human factors kind of studies. How well do the astronauts relate to their environment, the spacecraft, to give future spacecraft designers insights into how to design spacecraft more suitable for long-duration flights in the future.
Right, and I think there was a number of tasks along those lines planned for Scott today specifically. What about cognitive performance? How do you guys monitor that for crew members?
We're of course very concerned and very interested in the astronauts' cognition. Astronauts are selected and flown because they have substantial brains, and those brains have to interact with the environment. So we are doing some very simple testing of cognitive function, essentially a reaction time test, which tells us a lot about cognitive function at the very basal level, and some other studies which are largely pre- and post-flight with some in-flight sampling, in-flight questionnaires and testing that look at changes in the actual structure of the brain using MRI. And we'll do those. We can't do an MRI in flight, but we can do it pre-flight and post-flight, and do the same kind of psychological tests in flight as we do pre- and post-flight to see if we can correlate changes in the function on the test with changes in the structure in the brain. It's exciting, and it's the first time medical technology has allowed us to do this kind of really invasive, non-invasive kind of work.
There was another really unique opportunity with this crew in particular, Scott Kelly being a twin. So there's been a lot of talk about the twin studies in particular. Can you tell us how that's going?
The twin study is going very well. In this case, we actually had an experiment suggested by the astronauts. That doesn't happen very often. A biomedical experiment suggested by the astronauts, Scott and Mark, actually sort of came up with the idea themselves, and we jumped on it as a chance to really take advantage of a once-in-a-lifetime, not just once in a career, but a once-in-a-lifetime opportunity to make coordinated measurements on identical twins, one in flight and one on the ground. Mark continues to live the free-range life in Tucson. He's not living in a space station mock-up. He's not eating space station food. He's not exercising on Scott's schedule, but he does visit with us periodically and allow us to collect body fluid samples and do other studies, including the Chibis study. He is doing the lower body negative pressure study himself as a comparison with his brother's function in flight. He's also doing the cognition study and other studies like that. So we've just collected saliva samples last week, and next week we'll be doing the full panoply of sample collection, blood and urine, and yes, even fecal samples collected next week, as well as the full suite of psychological tests on Scott. And then in early October, Mark will come to Houston and do the same studies for us again. And then they will both continue, except for the Chibis part, they'll both continue in post-flight, the post-flight period for 6 months and maybe even longer, to allow us to collect data on Scott as he readapts, and on Mark as an example of somebody who never de-adapted.
So one final question. We've had a number of individuals, just a few who've stayed up there longer, but on Tuesday, that was the midway point for Scott and Mikhail, and now they're embarking on a new, longer mission than typical. What are the types of psychological aspects that you anticipate they'll be facing as they go into this second phase?
Scott and Mikhail are both extremely well-grounded, no pun intended, individuals in space. I expect we're going to see more of the same. I think they're highly motivated, extremely highly motivated. They're both volunteers for this mission. They'll do the very best anybody can do under these circumstances. I think they have considerable support from the ground, from their crewmates, from their family and friends, from people here in Mission Control and others in the infrastructure supporting this mission. I think I would bet they're not going to have real psychological issues. But one of the things we're doing in this extended mission is to see whether we can detect even subtle changes that might be harbingers of changes on other astronauts on even more challenging missions in the future. So we'll continue to look at them very closely, but I'll be surprised if we see anything that's really warrants a continued investigation.
Well, thank you so much. There's a lot of exciting science going on. It's I can hear the excitement in your voice, so we look forward to following along and as you said, supporting them. So thank you again for joining us, Dr. John Charles, again, the Associate Program Manager for the Human Research Program. Thank you.
Thanks.